now we're going to do a whole page of word problems involving percents. So the first one says, Ricky took a 35 question test and he got 28 questions right. What percentage of the problems did he get right? So if you think about it in terms of like how you would explain this to somebody else, if they said, well, how many questions did you get right? And you'd say, well, 28 out of 35. When you say that out of 28 out of 35, you basically just said a fraction. So if Ricky got 28 out of 35, and I want to convert that fraction into a percent, then I set it up against my percent notation, right? We've said this is the third time now I'm telling you that a percent is per 100. So take the fraction that you have, 28 out of 35, set it up against your percent fraction, and then you can cross multiply and solve. So we've got a 35n. This way we have a 2800. And then you would divide both sides by 35. You're probably going to want a calculator for this particular section. And when you take 2800 and you divide by 35, you get 80. And the beauty of using this little formula is you just slap a percent on your answer and you've got it. So what percentage of the problems did he get right? 80%. He got 80% of the problems right. So that would probably be like an 80% as his grade. A local animal shelter has 60 animals and 20% of the animals are cats. How many cats are at the shelter? Okay, I'm going to show you two ways to work this one. So there's 60 animals, and what we know this time is we know the percentage. Last time we had the full fraction on the left that we knew. Now what we know is the percentage. So what we're trying to figure out is, well, there's 60 animals, 20% are cats, so how many of the 60 animals are cats? I want to know how many. I know the percentage is 20%, but I want to know the actual number. So what I'm trying to find out is how many out of 60 would equal 20%. How many animals out of the 60 would equal 20%, so 20 over 100. And so if you can set it up that way, you've got 100x, and you've got 1200. When you multiply, and then we're going to divide both sides by 100. Maybe this math you can do in your head, and you're going to end up with 12. And this is not a percent, it's 12 cats. 12 out of the 60 animals are cats. And here's how you can check your answer. Well, what is 12 out of 60? That equates to 20%. So that's how we just checked our answer. So again, I just type it in there for this left-hand fraction. And 20 divided by 100 is 0.2 also. So we can see that that's the right answer. All right, so 12 cats. So the difference in these two problems is where the variable is located. On the first one, we were trying to find the percentage. Here we were trying to find the number of cats. So to answer this question, how many cats are at the shelter, it'd be 12. Another way that you could do this one, so I'll say or, you could do it this way. You could say, well, what is 20% of 60? That's the question that we're trying to answer, right? What is 20% of 60? Well, you can translate this straight to a little math equation. So what, I don't know, x, is equals 20%. Now we can't do math with percents, so we have to change them into decimal language before we do math with them. So that 20% would be 0.2 of multiplication 60. What is 20% of 60? And you can stick that in a calculator. If you do 0.2 times 60, you get 12. So you can either set it up like a proportion or you can set it up where you just translate it straight into math. But if you're going to use this method over here, you have to be able to come up with this question, because that question is what we're translating. What is 20% of 60? That's what we were trying to find out. So 2 ways to work that problem. I'll show you 2 ways to work this one also. James made $45,000 last year, and then he received a 2% raise. How much does he make now? So we've got to figure out how much money is the raise, like what is the 2% raise, and then we can add it on to his salary. So we're trying to figure out 2% of 45,000, right? 2% of 45,000. So 2% as a decimal is 0.02. Of means you multiply, and then 45,000. So let's see what that turns out to be. 0.02 times 45,000. 900. That's how much the raise is. That's how much the raise would be. So a 2% raise equates to $900. So his new salary would be $45,900, right? You just add his old salary to the 900, or add the 900 to the old salary, whichever way you want to add it. But it'd be 45,900. That's one way to work the problem, right? We're like, well, I wonder what 2% of 45,000 is, because that's how much his raise would be. And that's what we figured out. When we say of, that's multiplication. But you could also set this up as a proportion. So I'll say or, another way to do this one. You could say, well, how much does he make now compared to the original 45,000 that he made? Like, how much out of that original 45,000? We don't want to do the 2%. What we can do here is we can set it up like this. Now, how did I get 102? I got 102 because his old salary, 100%, plus a 2% raise means now he's making 102%. So percent. So do you see how the 102 is larger than the 100? So this x is going to end up being larger than 45,000. And if you cross multiply and solve, you get 45,900. But the trick is this little thing, put exclamation points. The trick is knowing that it's 102% once he gets the raise. So 2 ways to work that problem also. We'll do a couple more. A dress at Nordstrom Rack is on sale for $90. If the original price was $500, that's a heck of a deal. What percent was the discount? So I'm not asking what was the dollar amount discount. I want to know what was the percent. And you always compute percents based on like the original amount. So let's see, how much was the discount in dollars? If we take the original $500 minus the 90 that it is now, that's 410. That's the amount of the discount in dollars. But this says what percent was the discount. Okay, so 410 is how much you did not have to pay out of the original $500. So let's figure out, if we take how much is 410 out of $500, and I wonder what it is as a percent. 410, that was the amount that the dress was reduced. The reduction out of 500, I wonder what percent that is. So you put the discount here, and then you put the original price on the bottom. That's how you can set that up. Discount on the top, the discount out of the original price, what percentage is that? That's what we're trying to figure out. So you cross multiply, right? We're going to get some big numbers on this one. We're going to get 500N equals, big number, 41,000, and then you're going to divide by 500. We're going to get N equals, let's see, 41,000 divided by 500, 82. 80%. So it was an 82% discount. You paying $90 meant that this dress was on sale 82% off, right? If you put the 90 in there, you would end up getting, I think, 18%. So the $90 that you paid is 18% of the original price, meaning if it was 18% that you paid, it was 82% that you didn't pay. So you kind of have to think about it backwards if you use the 90. So I would encourage you, if you're trying to find the percentage that the discount is, you want to use the discount number in your calculation. So the percentage of the discount, 82%. That's one heck of a deal, right? All right, last one. Amy bought a dress for $144 on a 20% off clearance rack. What was the original price of the dress? So she got it for $144. That is the 20% off price. So we are going to kind of change our perspective a little bit. If she got 20% off, that means she only paid 80% of the dress, right? 20% off means she paid 80% of the original price. So 20% off, if they took 20% off the price, then she paid the other 80%. So it's an 80 that we're going to be looking at here. So I want to know if 144 was the sale price out of whatever the original price was. I know that that 144 that I paid was 80% of the original. So the 144 that I paid equates to 80%. 80 over 100. The mistake students usually make is they put a 20 here. But this is the discounted price out of the original. So what we're going to be solving for here is the original. So it's kind of like the last problem where we have the discount amount on the top and then the original. So this is the discounted price, 144 out of the original. And if we solve this one, if we cross multiply like that, we'll get 80x equals 14400, and then by now you know you divide both sides by 80, and if I take that number and I divide by 80, I get 180. So that means the dress was originally $180, but Amy only had to pay $144 because it was on a 20% clearance. So how you can check this one is you can say, well, I'm going to take that $180. If it was on a 20% off rack, well, I wonder what is 20%. So if I multiply by 0.2, $36 is how much they're going to take off. So if you take 180 and you reduce it by $36, you get the sale price. So you can kind of play around with the numbers and check your answer. But the kicker on this one is that I didn't use 20 in my calculation. I used 80 because the $144 was the 80%. If you think of it kind of this way, like let's say this is the original price. Okay, this whole thing is the original price. It was marked 20% off. So if that 20% was marked off, that means there's 80% that she's paying, and that's why I used the 80 in my calculation. Another way you can do this problem, I'll say or, you can say 80% of the original price is $144, right? 80% of the original price is 144, so 0.80 of the original price, I don't know, equals 144. And how would you solve this little equation? You would divide both sides by 0.80. And when you divide 144 divided by 0.80, you get 180. And that's the original price of the dress. So original price, Well, you know the original price was higher than 144, but what students try to do is take 20% of the 144 and add it back on, and that's actually not the correct way to go about it. You have to flip your perspective to this 80% perspective, and then if you'll set it up as a proportion, it's very easy to solve. I actually think that's the easiest way to do it, but it's that 80% you got to be careful of. So these are all the different types of percentage word problems that you might see in your homework and on tests.